Hello everyone, today I'm going to show you how to find the flexion axis of your femur or your knee from a sphere fitting to the posterior condyle. So basically you can find the flexion axis of the femur from the two spheres that fits to the femoral condyles, and the axis that goes through these two spheres could guide you to have an estimation of the flexion axis of the knee. So to do that, I'm going to use a ParaView software. ParaView software is very good for visualization, addition, selecting points on every other things on your models. I'm going to show on next video, I'm going to explain how to download ParaView and how to use this software. So to find a sphere on your femoral model, you need to have that femoral model. You may already know how to create a 3D reconstruction of a model from your CT scan images, or you can find a femoral model on the internet. So I have my model here. I go to File, Open, and then I have my model here. Femur. I have my model as a STL file. You can also use VTK file, and I select OK. Okay, this is my model already reconstructed from CT scan images. So basically, I'm going to fit a square in here. A sphere in here to the lateral condyle, and another sphere here to the medial condyle. To do that, if you select points here on your posterior femoral condyle, this can guide you to the best sphere that can fit to this condyle. So basically, I'm just going to zoom in a little bit. To select the point on this condyle, I'm going to choose select point with polygon. And then I'm going to hold the left click button and select the points on this condyle. As you see, I'm just going to do like a circle shape thing and select the area of the condyle that I like. So basically, we can make a sphere that fits these points and fits the medial condyle, as you see here. Okay, to export these points, I'm going to go here, select split horizontal, and then I will click on spreadsheet view. So these points are all the points that is available on this model. So to just select the point that we just selected using polygon, I'm just going to select show only selected elements. And from that, when I just show the only selected element, I'm going to click on export spreadsheet. So basically, I'm going to export all these selected points here. Just going to use the same folder, and I'm just going to say this is medial condyle. Okay. And that saved this as a CSV file in my computer. Again, to do another sphere fit on the lateral condyle, I'm going to go on select points with polygon and select the points here. You have to make sure that you don't select any points on these bony shaped things. These are ossifieds, these are not condyles. And you'll have to make sure that you are not selecting points here. So basically, if you are selecting like something like this much point, you're selecting here as the points on here as well. And this is gonna make the sphere that you're gonna fit from here to here. Here it's gonna ruin this sphere. So basically, you would go on clear selection. Again, I'm gonna zoom in a little. Select the points with polygon. Actually, I need to take this a little bit. Again, I'm gonna select point with polygon and hold the left click button and select the area I want. If you wanna select a little bit more points, for example, here, you need to hold the control key and again select the polygon and select more points here. All right, I'm gonna do the same thing to export the points. So again, spreadsheet view, show only selected elements, and then export. So I would call this lateral condyle and select OK. And again, it's going to save it as a CSV file. It's going to give me two CSV files, one for medial condyle and one for lateral condyle. So as you see for lateral condyle, these are points ID, just ID numbers for each point, and this is 0.0, 0.1, and 0.2, which is X, Y, and Z for lateral condyle. Again, for medial condyle, you have the point ID here, and then X, Y, and Z, or 0.0, 0.1, and 0.2. All right. So to use all these data and make a sphere based on these data, you need to use a built-in function, or like a function that is already written by people, as available on MathWorks website. I already downloaded this. This is a really good function to make a sphere fit based on X, Y, and Z, the position of the points. So I already downloaded that and opened up on my computer. So basically, this function, you need to have your points as your input data, and it gives you the center and the radius of the sphere. Okay, so I'm just gonna say points. I just made a new variable, and from lateral condyle, I would say lateral points. Lateral points. Okay, so lateral condyle, I just select all these X, Y, and Z. Make sure that you're not selecting the point ID, and selecting this, all the points from here, and copy. And I basically, what I did is that opening this variable, and I just paste them here. Okay, so I have my lateral points here and medial points. Again, I will make a empty variable and go to medial points and select all these ones. You could also use import function from the MATLAB to import your CSV files. This is just a very easiest way. No coding required. So basically, you have your lateral points and medial points data already imported to the MATLAB, and the only thing you need to do is just copy this function. And here, select, paste it, and say lateral points instead of X. So this is going to give you a lateral center and lateral radius. Okay, and enter. So your lateral center is -41, -4, and -7, and the lateral radius is 22, which makes sense. 22.5 millimeter is a good radius, so your sphere is not off. Again, you can just copy this, Control-C, and make it here. I'm just going to use my medial points as an input, so I'll make the a sphere for my medial condyle as well. So this is going to say medial center and medial radius. Now I have my medial center, 9, -14, and -12, and my medial radius is also 21. All right, awesome. So now I have my medial center, which is the center of the sphere that fits to the condyle. So I'm just going to close this, just going to zoom out to see so basically from this point, your medial center, to this one, your lateral center, this is your axis. But if you want to see that the spheres that you already fit to these condyles make sense and is in a good place, you need to make those spheres on the ParaView. So on the same window that you opened up your femoral model, we would go to alphabetical and say, I want to make a sphere. Okay, so a sphere 1 or medial sphere, you can enter your X, Y, and Z position of that from your basically medial center that is already measured. So I'm just going to copy this, and from that paste it here. Again, I'm going to copy this, just paste it here. You can enter this by hand as well and copy this and paste it here. Okay, just gonna make it radius of 5. To see, so a sphere is actually inside this condyle. So to see this, you need to you need to decrease the opacity of the model. So basically, just gonna decrease the opacity of the, and what you see here, you have a sphere here. Just gonna change the color to red so you could see that better. As you see, there's a sphere that is inside this condor. If I increase the radius of a sphere to 21, it was 21, I guess, as you see, or a little bit bigger, 22, you see there is a sphere that fits to the condor very well. If you look at that this view, as you see, you now have a sphere that fits to your medial condyle. So your lateral condyle sphere also can be made using the same method. I'm just going to call this lateral sphere and use the lateral center that's already measured from here. Copy X here, again Y. Just going to paste it here and Z of the center here. And again, I'm going to just say that I have a, for example, 5mm radius, and I'm just going to change the color to blue. As you see, there's another sphere here. And if I say that I have a radius of 22, okay, so one thing I do, I just say 22 and then I click here, but I could click on the apply, so it's going to apply that. So if I say that make the radius 23, I'm just going to click on the apply and it gives me the sphere. As you see, these two spheres all fit very well to the posterior condyle and to the condyle of your femur, and this is basically the flexion axis of the axis of your femur. If you want to find the point that is the center of the femur, you can use again the data that you have here, lateral center and medial center, and say that center of the femur is equal to lateral center plus medial center divided by 2. So here is the coordinates of the center of the femur. So I'm just gonna make these a little bit smaller. This also a little bit smaller by the radius of 5. And then I'm gonna make another sphere. To make a sphere, I should have said that you should go to source, alphabetical, and sphere. So center, I'm just going to call the other sphere center, and I'll bring the coordinates from here, center of femur. Just going to copy X coordinate, paste, copy Y coordinate, paste, and the Z coordinate. I'm just going to make this radius of 5. I'm just going to apply. Okay, as you see, I'm just going to change the color. The yellow sphere is the center of the femur, and this is basically the axis of the femur, or axis of flexion axis of the knee. It's estimated flexion axis of the knee. I can in the comment I can mention the paper that explained this method. I just wanted to show you how you can actually measure the flexion axis of your femur very easily using just ParaView and MATLAB. Good luck with your study. Let me know if you have any question. Goodbye for today.